Thank you, Wes, and thanks for all you guys being here at this late time in the conference. Wanted to start with just a word on HDR because I'm betting most, or maybe all of you have never heard of HDR. We're a civil engineering consulting firm. We were established in the United States 100 years ago this year, and we've grown globally. We're now about 10,000 people. We have offices in Asia, Middle East, a lot of offices in North America, and a couple offices here in Australia, Sydney and Brisbane, and I work out of the Brisbane office. So when I started to prepare for this presentation, I kind of had a thought. I zoomed out and I thought, gee, you know, what is the potential for solar on landfills here in Australia? So I learned that there's about 600 mid-range to large landfills in Australia, and they define those types of landfills as having an average area of about 35 hectares. And so that's about 21,000 hectares. The rule of thumb for solar power is you need about 1 hectare for about 1 megawatt of power. The energy demand in an Australian household is about 3 kilowatts per day. So that equates to about 7 million households if we were to get solar on all of the landfills. I thought, wow, that's pretty big. So this is what I'm going to be talking about this afternoon. I'm going to keep it light. I've got a lot of photos, got a couple of videos. Hopefully they'll work. So I'm going to get into some geosynthetic caps and maybe some different stuff you haven't seen yet. So with regard to geosynthetic caps, one of the big advantages is that it is low in maintenance. In other words, there's no soil on top. It's just basically an exposed geomembrane cap. So you can really easily see any cracks or damage, and the quality of the stormwater was, of course, much higher. This is just a graphical comparison of a traditional cap system and an EGC. As you can see, that all of that soil is eliminated, so there's potential cost savings with eliminating that soil, and also potential additional revenue from that additional airspace. I think I mentioned most of this already. The advantages of an EGC, the membrane's flexible, so it accommodates settling, and performs really, I think, to me, one of the biggest advantages of an EGC is if you have particularly legacy landfills that have very steep slopes. The EGC is perfect for that type of landfill. You don't have to worry about compacting clay, and there's also some construction time savings because you're not compacting the clay and getting all that extra material, and also provides a nice surface for solar panels. Those are different design considerations. The most important is wind uplift. So you do some computer modeling to predict what the wind uplift might be, and that will dictate your ballast design. It's most common to ballast EGCs with an anchor trench, both along the slope, down the slope, and also across the slope. You can anchor them. You'll also have to consider how you're going to access the liner so you can inspect it. You can use ATV vehicles, but just be aware that you can't drive on them with all types of equipment and such. Here's some photos of some existing EGCs. These are all at landfills in Florida, and I've actually worked at 3 of these landfills. The top right is the white one is an LLDPE material that was put on a landfill as part of a research project for a bioreactor. They wanted to measure everything that went into the landfill and came out, so they wanted a really good seal. The black lines are actually piping on top of the landfill. The bottom right is a green on the side slopes, not the white material. The white material is just a rain flap, and that will be sacrificed as the landfill goes higher. But there's a green HDPE textured material on the side slope. And likewise with the bottom, your left photo, you can see that part of it, the darker green on the inside, is the EGC material. And then it's a traditional grassed soil cover system on the rest of the landfill. The top landfill on the side slopes again has a different material called TPO. It's thermoplastic olefin, and it's a common material in the roofing industry. So most often I get asked, well, gee, how long are these, EGCs going to last? Well, the most common materials, as I just mentioned, are HDPE, LLDPE, and TPO. They all last well over 30 years. The testing was done under climate conditions in Texas. So just as a point of reference, I put some other weather conditions in here from Sydney, Brisbane, and looking at Florida. Again, I have a lot of examples from Florida, so you can see the temperature and sunshine hours and such are pretty comparable to Texas. So these EGCs can be designed for major storms. As I said, a lot of these examples are from Florida. Florida is known for a lot of hurricanes. This is a visual, an aerial photo of an outline of Florida with a hurricane approaching, and the red stars are actually EGCs that have been existing for, one has been existing for more than 15 years. Saw a photo of this earlier. This is the part EGC, part traditional cover. This is the first EGC that was done in America. I worked on this project, and it was built in 2001. In 2004, 3 hurricanes crossed this landfill and got about 500 mil of rain, and there was no major damage, so we were all very happy about that. As I said, the stormwater impacts are pretty evident in these photos here. This is a landfill that has, or a facility that has a traditional covered landfill, and another landfill that has an EGC, and just wanted to show you, there's this close-up insets of the stormwater pond on the right. That's all red sediment from the clay material, from the cover material. And the other pond is nice and clean. So in addition to EGCs, there's another geosynthetic cover system that uses artificial turf. There's one brand that's called Closure Turf, and it's actually a combination of different materials. There is a geomembrane at the bottom layer, and then there's a geotextile for stability, and then the top layer, of course, is the artificial turf. Now, the geomembrane is welded like a typical installation, and then the turf is sewn together. Now, for the ballasting is different on this type of system, and you all maybe are familiar with on tennis courts where they have the artificial turf in the sand. That's the same type of system here. This top right corner, you can see the guys are applying sand by hose, and it really gets in between the sand blades, and it does not erode. They've done wind tunnel testing, I think up to 200 kilometers an hour and also some rainfall intensity, I think 150 mils per hour, to see if this type of ballast holds. Now getting on to the solar part of the cap. Generally, there's two types of solar panels we put on landfills. The rigid crystalline type is very common, the ones that you see on rooftops and fields and such. They've been around quite a while. A newer generation of panel is a thin laminate, and the efficiency has really improved in the past few years. So it's getting quite close to the efficiency of the rigid crystalline. As you see, the design life is very comparable, but one difference, and I'll talk about differences in a minute, is that the rigid crystalline systems are usually only used on the top deck of the landfill because of the weight. Here's just some photos of, again, these are all in the U.S., of solar caps. The one on the right is a green TPO material that has the laminates on it. The one in the bottom middle is the top part that's very green. That's that closure turf type of material. The side slopes have a traditional cover, so you can see there's a bunch of erosion there. But on there, there's the crystalline type of panels. We have crystalline panels on the bottom left that are just on a traditional type of soil cover, and two other photos of the laminate type systems. So these laminate panels are very flexible, so they can accommodate settling. As I said, the huge advantage is to put them on side slopes, particularly steep side slopes, or batters, as you say. And there's really very little load on the landfill and virtually no wind uplift. So these laminate panels can either be applied in the field fabricated, or they can be fabricated in the factory. So now I have a video that explains a bit more about the system, so hopefully it'll work for me.
The solar cover system starts with a specially formulated liner or geomembrane that offers high strength and flexibility. It's engineered for long-term outdoor use in hot and cold climates, even extreme weather conditions. Flexible solar panels are then adhered to the geomembrane on top of the liner, and the sun's power is converted to usable energy.
Landfills are ideally suited for solar energy covers because they consist of large open areas, specifically with sloped areas, which are ideal for solar collection efficiency.
Unlike rigid solar panels, which have been used at other landfills, Republic Services' solar energy cover system uses flexible photovoltaic solar collection that can be directly adhered to the liner. The laminate solar panels are flexible strips, less than 1/4 of an inch thick, that can be applied side by side or end to end, which allows greater freedom in designing grid layouts and maximizes solar collection while adapting to a landfill's natural contours. The large solar arrays are typically located on the top deck and southern-facing slopes of the landfill to maximize the hours of sunlight exposure throughout the year. The resulting solar cover system can be designed to cover 10 to 20 acres or even more in a custom, aesthetically pleasing, and economical way. The result is more renewable, clean energy, this time directly from the sun. The solar energy cover system is engineered to provide superior containment, stability, and protection for the natural environment, and is uniquely designed to meet the closure requirements of an individual landfill. The system is closely monitored, both during installation and operation. Solar power technology converts sunlight directly into electricity whenever sunlight strikes the photovoltaic modules. The amount of electricity produced by a system will vary. More electricity is generated when the light is the most intense on a sunny day and strikes the solar electric system's modules directly. The solar power technology produces electricity directly from electrons that are freed when sunlight interacts with the semiconductor material in the solar electric cells. These cells are the basic building blocks of the system and are wired together to form photovoltaic modules. The modules are then connected to an electric utility through an inverter that changes the direct current, DC, produced by the cells into alternating current, or AC, which is the same form of electricity supplied by your local electric utility and can be used to operate heating and cooling systems, appliances, lights, and other uses. By reducing the need for fossil fuels as an energy source, Republic's renewable energy...
Great, thanks. This is a private facility in Texas. So one of the advantages of doing the field fabrication is you can easily make adjustments in the field if you want to change something. However, it's just it extends the construction time a little bit. So I've got another short video of a field fabrication, and this is at a site, very, very large landfill near Atlanta.
We are shipping in photovoltaic rolls. We have factory bonded the photovoltaics directly to the geomembrane, and we unroll them here on site. We weld them together and create a monolithic cover on this landfill. Every single one of these components are manufactured in the United States.
There's about 7,000 of these unisolar panels on this hill. Each panel right here is actually 144 watts of solar. These are Teflon coated, very durable. You can walk on these panels. You can actually do the inspection of the wire system itself. You're looking at about 1 million linear feet of wire. That is a lot of wire.
Each of these solar arrays are roughly 250 kW. That matches with each inverter. So you have 4 inverters rated for 260 kW. The system overall is operating at 1 megawatt in total. That will be equivalent to producing energy to about 224 homes according to the EPA calculator.
Great. So the solar on landfills have been around the United States for a while. This graph starts back in 2006, but in the last few years, it's really taken off. The amount of power from landfills in the past 4 years has increased by 5 times, and I suspect a similar trend will be happening in Australia here soon. Again, I'm probably running a little bit short on time. Okay, so just some other. This is also a facility in Georgia near Atlanta that they have put the closure turf on it. I'm just trying to just show you different examples of what you can do. And with the closure turf, of course, you would use the rigid type of panel, solar panels. This system is one of the first that was done, and it's in near San Antonio, Texas. It's using the TPO, textured TPO material with the thin laminates on top of it. It won some awards. Swan is the equivalent to WAMA here, and likewise, this is, I won't concentrate on this slide. This is the one you saw in the second video, and that was actually permitted as final cover. So solar caps in Australia, HDR has done a feasibility study for a landfill near Brisbane that we completed last year, and we are in the middle of completing another one for a landfill near Melbourne. The only landfill that I'm aware of that has solar panels on it is near Adelaide, and those are the more traditional crystalline panels, and that was commissioned the end of last year. LMS Energy, I knew they were here at the conference, but they would know a lot about that. Just wanted to touch base about regulatory approval in the United States. About 1/5 or 20 of the states have approved these EGCs and things like closure turf as final cover, along with Puerto Rico. So looking at Australia, none of the states specifically say that an EGC or an alternate cover would not be allowed. It's just a question of proving its equivalence or showing that it meets the intent of the guidelines. So again, just to get started in your project, just wanted to mention you would start with a feasibility assessment of your particular site because they're all so different, and then going into the design and then developing really site-specific specifications. And that's all I had. Thank you.
Thanks very much, Judy. If anyone has any quick questions for Judy before she...
Yes.
Hey, Judy, just one quick question. How did the feasibility study stack up for the Brisbane one that you looked at?
It turned out that it wasn't feasible, and the reason why was that the landfill had already had a traditional cap on it, so it would be, just didn't make sense from an economic point. You have to kind of think about it in advance of that, yeah.
When you mentioned Brisbane not stacking up, was that on the basis that they were going to be selling the electricity to grid, or if you were using the electricity generated yourself? Would that have had a significant effect on the feasibility?
I don't recall. I think the deciding factor was, in fact, that it was just already closed. So I don't recall the details of that electrical, but I can get back to you about that.
Just interested to know, some of the pictures you showed had solar panels completely covering caps and some were patched. Why were the patched ones not completely covered?
Oh, like in one of the, where there was an exposed EGC, like an exposed cover, and it seemed like the panels were really far apart. Yeah, that was one of the older style. Now the panels are such that they can install them much closer together. So that's almost kind of an older version. Good catch. As an EGC intermediate cover? Well, initially. The oldest one in Florida was only approved as, an interim cover or intermediate because the regulators were really unsure of how the material was going to fare, and extra pieces of material were welded onto the cap, and every year went through a very rigorous evaluation of the material, and eventually they did approve it as final cover. But I think for temporary purposes you could, but the whole idea would be, is from cost savings point, you'd want to obviously do it as final cover, yeah.
And this last question, yeah.
Obviously there are different stormwater characteristics for this cover and traditional.
Yes.
So different stormwater characteristics.
Yes.
Can you talk about what additional capacity you need and what additional infrastructure you need for a system like this where water's just going to run straight off?
Yeah, well, of course, it's really site-specific. I don't have real general numbers to give you, but certainly, yes, there will be higher volume and quicker. So, yeah, I mean, I don't have a formula to say, oh, it's going to be X percent more volume that you're going to have to treat. It's just, very particular to the site.
Thanks very much, Judy.
Okay, great, thanks.